In lesson 4.3, we're going to be talking about the angle relationships in triangles. And the first thing that we're going to discuss is the triangle angle sum theorem. So if I take a look at the angles of my triangle, the sum of the measures of the angles of any triangle is 180 degrees. So over here, the measure of angle A plus the measure of angle B plus the measure of angle C should add up to 180 degrees. They're going to ask us to take a look at finding some angle measures, and as I look at example A, I'm going to look for my missing angle measures. In diagram number 1, I can see that in order to find my missing angle, I'm going to have to come over here to the triangle on the right and look to find my missing third angle. So I'm going to take 180 and subtract 36, subtract 84, and what we would find is that this angle here would be 60 degrees. Now also, because I have this right angle, that would tell me that this angle of my triangle would have to be 30 degrees. By angle addition, those would have to add up to 90. So again, now I'm looking at my triangle on the left, and 180 minus 30 minus 86 would tell us that this missing angle here would have to be 64 degrees. As I look at my diagram number 2, I'm actually looking for 3 different angles. The measure of angle 1, 2, and 3. And as we look at this diagram, different people will approach this problem in different ways or in a different order. You don't have to find the angle measures in order. You could jump around, but I think we can all agree that angle 3 would be an angle that I would not be able to find first. So as I look at angle 1, I do see that I have a linear pair right here. So 180 minus 57 would tell me that angle number 1 would have to add up to 123 degrees. As I look at angle number 2, I see that I can use this smaller triangle on my left, subtract from 180, and I would find out that angle 2 would be 52 degrees. Sometimes I like to write them right in the diagram so that I can keep better organized or give me a better visual. Now when I look to find angle 3, there's actually 2 different ways you could look at this. Most of the time people see the smaller triangle on the left and they would subtract from 180. But we could also look at using the larger triangle, knowing that I have my 52 degree angle here and adding those together, the 99 degree angle. Either way, when you subtract from 180, we would find that we would have a 29 degree angle. As I look at question number 3, they have one angle as 84, one angle as x plus 51, and another as x plus 59. So this one we're actually going to have to set up a little bit of algebra. If I have my angles added together, x plus 51 plus x plus 59 plus 84, I know that my sum should be 180. Now I went ahead and I'm going to combine my like terms. If I have x plus x, and 51, 59, and 84 would give me 194. Subtracting 194, I end up finding out that x comes out as a negative 7. And at first I was a little bit alarmed. However, as I look at my equations, x can be a negative number because when I plug it back in or I find my missing angles, negative 7 plus 59 still gives me a positive angle measure. Negative 7 plus 51, positive angle. And so I am okay there. Down below, we're going to talk about a couple of new pieces of information, but we do introduce a new vocab word, and that vocab word is a corollary. A corollary is a theorem whose proof follows directly from another theorem. Here are two corollaries to the triangle sum theorem. So related to our triangle sum theorem, if we take a look at the acute angles of a right triangle, what would we notice? Angle A and angle B. What do we know about them? Well, if we have a right angle and angle C is 90 degrees, would you agree the measure of angle A plus the measure of angle B would have to equal 90 degrees? Therefore, my two acute angles are going to be complementary. Also, knowing my angles of a triangle add to 180, the measure of each angle of an equiangular triangle is, well, if all of those angles are congruent, we can think about 180 divided by 3. Therefore, each angle would have to measure 60 degrees. You may be asked questions like example B, where they state the measure of one of the acute angles in a right triangle is given. What is the measure of the other acute angle? The key here in our directions, it says we have a right triangle. And so referring to the corollary above, my two acute angles are complementary. If one of them is 63.7, then the other one would have to be its complement. And we'd simply subtract, finding out that that other one would be 26.3 degrees. In number 2, it tells me that that angle is x degrees. Well, what would the complement of that be? Well, the complement here would simply be an expression, and I would write that as 90 minus x degrees. It would be whatever is left over after we subtract. In the text, it is also discussed about adding information to our diagrams. And they describe an auxiliary line as a line that is added to a figure to aid in a proof. So usually when you're adding a line or line segment into your figure, it's because you are working on a proof. In my diagram over here, they would consider line L our auxiliary line, a line that has been added. And you can see by adding that, we have formed some new angles. We're going to be talking about those in the examples to come. And so we're going to move down here. Taking a look at our triangle, they have extended one side, almost kind of like adding an auxiliary line. And when they did that, I now have formed what they have labeled as angle 4. Obviously, the angles on the inside of my triangle we're going to refer to as the interior, and the angle on the outside is going to be my exterior angle. Well, if we take a look at some angle measures, I'm just going to go ahead and say, let's pretend this was a 60-degree angle, and let's pretend this was a 70-degree angle. Now, even though those aren't drawn quite to scale, with those two pieces of information, would you agree we could find angle 3 and angle 4? 60 plus 70 is 130, and in order to add to 180, that would therefore have to mean this would be 50 degrees. Now, seeing that this is a linear pair, if angle 3 is 50 degrees, angle 4 would have to be 130. Well, what ends up happening is that my two angles over here, these two numbers, if we add them together, we will actually get our exterior angle. That is called the exterior angle theorem. The exterior angle theorem says the measure of an exterior angle of a triangle is equal to the sum of its remote interior angles. Remote meaning away from. And so when I have an exterior angle here, the remote interior are the ones that are away from my angle 4. And so in my diagram here, angle 1 plus angle 2 would have to equal angle 4. My remote interior would equal angle number 4. You can use the exterior angle theorem, but sometimes there are questions where it's not the only way to go about solving. So when I look at example C, and they're asking me to find the measure of angle 1. First of all, I'm going to darken this diagram a little bit and extend. But my measure of angle 1 is this angle right in here. Now, because of the information that they have given me, if this angle is 90 degrees and this angle is 40 degrees, I could use my exterior angle theorem, because I know that if I take those remote interior angles, that should equal angle number 1. 90 plus 40 would equal 130 degrees. Now that's not the only way to do that, because some people may say, well, if this is 90 and this is 40, this would be 50. And 180 minus 50 would also give me 130 degrees. So in that case, you could solve it either way. However, looking at the diagram in problem number 2, it doesn't work out quite that simply. Here, we are looking for the measure of angle JKL. First, you need to be able to find that angle measure. JKL, in that order, angle JKL would be right along in here. And so I'm actually looking for that measure right there. With my triangle, the easiest way to go about solving this is going to use my remote interior angles. Because again, these are remote interior. If I add them together, it should give me my exterior angle. So I could set up my equation as x plus 50 equal to 2x minus 15. If I'm going to solve this, I would add 15 to both sides, I would subtract an x, and I would find out x is 65. Now that's partway to my answer, but if x is 65, I need to go ahead and substitute that back in to find my angle measure. 2 times 65 minus 15, and we would find out that's a 115 degree angle. Finally, we're going to take a look at the third angle theorem. The third angle theorem, let's start by just taking a look at this diagram over here. In my diagram, it is showing me angle B congruent to angle E by the markings, and angle A congruent to angle D. If that is the case, would you agree that, well, angle C would have to be congruent to angle F? That is the third angle theorem. The third angle theorem says that if two angles of one triangle are congruent to two angles of another triangle, the third angles must also be congruent. So as I take a look at solving for angle P and angle T in example D, at my diagram, I don't have enough information to add my angles to 180 degrees. But I do see that angle N and angle R are congruent. Angle N and angle S also congruent. What does that mean? Well, that means that by the third angle theorem, angle P must be congruent to angle T. So, that also must mean, by a substitution, that 2x squared must equal 4x squared minus 32. Now, I do want to show you in solving this, even though it has an x squared term, we're going to approach it the same way. A lot of times kids may start by subtracting 2x squared, and that is fine. But I want to point out to you that when you have these kind of cancel out over here on the left, you're going to actually put a 0 there. 0 equals 2x squared minus 32. Sometimes kids forget that part, and then they kind of lose their equation. If I add 32 to both sides, I'm going to end up finding that, throw this over here, 32 equals 2x squared. I divide by 2. 16 is equal to x squared. Now I could use that because both of them have the x squared in their expressions, but if I needed to solve for x, I want to point out that we would have to take the square root of x, and that we would actually find that there are two answers, plus and minus 4. Now, it does not ask me for x, it asks me for the angle measure. So I'm going to have to come over here and substitute. If I take 2 times x squared is 16. 2 times 16 tells me this should be a 32-degree angle. Do I have to check this one? Well, it'd be a good idea to make sure that they get the same number. And so as I take 4 times 16 minus 32, I do find out 64 minus 32 that I get 32 as well. If you have more questions on this, you can see the online video sponsored by our textbook, but I also encourage you to come in and visit with me.